Hi everyone, I'm Won-Lee. I'm going to introduce new terminology, significance probability, say p-value. This one, significance probability, is important when using computer. Computer program just give you p-value, okay? So you have to understand exactly what p-value is and how to use p-value for interpreting your statistical analysis. Let's see anyway. First, what is significance probability? Significance probability, say p-value, is valid when using a computer to solve your problem because statistical software programs have the necessary probability distribution formula built in. Okay, software program built in allowing for accurate probability value calculation. We do not use probability distribution formula for chi-square or t. It is very difficult. We cannot solve the probability, say, p t greater than 1.2, even degrees of freedom 30. Okay, we cannot solve this probability. Computer can solve this probability because computer software has the t distribution function built in. If you want to test a hypothesis, the statistical program calculates and provides p-value. So it is essential to understand correctly what the p-value is. Let's see, for example, we try to two-tailed test for mean like this. H0 mu equal to mu 0 versus this is some specific value. Okay. Previous example we took it as 50. H1 is mu is not equal to mu 0. The user, we, will input the data in the computer, and at this point, the sample mean value x bar, small x bar, will be calculated. The significance probability is obtained by calculating the area. In this case, area means probability of the tail corresponding to this x bar value. Say x bar here, okay? Then the probability, this one, will be calculated from t distribution. If the p-value is small, this p-value small, it indicates that x bar sample mean value is far from mu 0. Mu 0 is in H0. In that case, we reject H0. Understand that? Then, based upon the sample mean value x bar and standard deviation small x calculated from the data, the computer calculates and provides p-value as follows. In this case, x bar lies at the right side tail here. Okay, so p-value doubling. Yeah, doubling it because it is two-tailed test. So we have to consider both tail. That's why double it. 2 times probability of random variable x bar greater than sample mean value x bar, okay? Because it's a right side tail. If you have x bar here, then it will be what? 2 times probability x bar less than small x bar when your x bar is here. Okay? So x bar can be standardized by this x bar minus mu 0 because we test the hypothesis under the assumption H0 is correct. Mu 0 divided by S over square root of n. Same procedure here, x bar minus mu 0, S over square root of n. Then this will be t random variable, and this is calculated t value. So the computer program has the t distribution built in. So calculate this probability times 2. That is p-value. When you test two-tail test for mean like this, okay? No problem. If the user intends to conduct a one-tail test, for example, for the mean, for example, mu 0 equal to mu less than equal to mu 0 versus h1 mu greater than mu 0. then x bar, small x bar, should be right hand, right side of tail. Okay, so we have to, concentrate on, focus on one tail. This is a two-tail test, so we focus on two sides, two tails. That's why doubling it, doubling it. But if one tail, then we just concentrate on one tail. This one is a right hand side tail. The p-value provided by the computer needs to be divided by 2 because to obtain appropriate one-tail p-value. Because many statistical software used to assume that the user, is conducting a two-tailed test. Okay? So we have to divide by 2. You understand that? I think this one is two-sided, two-tailed test. If one-tailed test for mean, then the p-value provided by computer should be divided by 2 because we want to get the tail probability only one side. Okay, that's it today. Anyway, I'm going to explain later how to use p-value. It is also important thing. Okay, thank you. Bye.